Okay, when I look at this problem, the first thing I notice is that I have Na2CO3. That's not a strong acid. That's not a strong base. It's not on list I memorized. It doesn't strike me as something that would be a weak acid. It doesn't start with H or end with COOH. It's not on my weak acid or my weak base chart. So it's probably not a weak acid or a weak base. It's likely a salt. I can check, does it have a metal and a non-metal, or either one of those subbed in with a polyatomic instead? Yes. What I have is a metal, sodium, and a polyatomic ion, carbonate. So we are dealing with a salt. Metal and a polyatomic make a salt. That salt can dissociate into two ions, sodium and carbonate. I would balance it. And then one of those ions is probably going to make it an acidic or a basic solution. Theoretically, it could make a neutral solution, but given that I'm asking you to find the pH, I'm going to make sure it's an acid or a base and not something neutral. So one way is just finding one of these ions on your weak acid base chart. As soon as you find one of them, you can proceed with a weak acid or a weak base problem. How we learned it through the videos was taking each of the ions, so the sodium ion and the carbonate ion. We don't have to worry about the fact that the sodium ion had a coefficient of 2. That won't affect how we go through this. And we test them by reacting with water. So asking ourselves, since the sodium's a positive ion, what ion of water will it react with? The negative part, the OH part. That sodium, if it's going to react, is going to react with the OH, and that would leave H+. For the carbonate, CO3, because it's a negative, when it reacts with water, it would steal an H. Just one H from the water. Sorry, that would be -1 now. And therefore, it would release OH-. Now, the problem is, both of these reactions aren't going to be happening. It might be that neither are happening, but we need to see which one could be. So since NaOH is strong, it would never actually stick together. Therefore, this reaction would never happen. If that were true of the next reaction, neither reaction happens, then we have a neutral solution. But HCO3 is not strong, is something weak. So this reaction can happen, and we can do an acid or a base problem. So since that reaction can happen, and that reaction produces hydroxide, we know we're making a basic solution. So we know we're going to treat carbonate as a weak base and just do a weak base problem from here. In order to do that, I need the molarity of the weak base. So taking the 1 gram of sodium carbonate and finding the moles, grams equals moles times molecular weight. Sodium is 23 times 2 plus the 12 from the carbon plus 16 times 3 for the oxygen. We get a molecular weight of 106. So my moles of sodium carbonate is 0.0094. I can find my molarity of sodium carbonate by taking those moles over, let's see, 500 mils would be 0.5 liters. So my molarity of my sodium carbonate is 0.01886, 0.019. Sodium carbonate is in a 1-to-1 ratio with the carbonate. And it's that carbonate ion that's my weak base, right? When we are testing the ions against water, whichever ion reacted with water to form the basic solution, that's the ion that I am working with. So I care about carbonate as my weak base. It's in a 1-to-1 ratio with sodium carbonate, and therefore I already know my molarity of my carbonate. So if I go back to that reaction that I had, it's the carbonate reacting with water. I can fill out my ice chart. For carbonate, I now know its molarity is 0.019. 0, 0 plus X, X plus X. I'm just doing a regular old weak base problem. Nothing different here. When I'm doing a weak-based problem, I want a KB value, and I'm always looking for the value from the chart for whatever thing, whatever reactant is on the left, the CO3, not ever something from the right. So I go get the KB for carbonate, bottom part of the chart, first column, a little more than halfway down. My KB is 2.1 times 10 to the negative 4. And that's going to equal x squared over my molarity. Sorry, it's messy. So 2.1 times 10 to the negative 4th equals x squared over 0.019. I still have that number in my calculator, the 0.01886. So I multiply that by 2.1 times 10 to the negative 4th. I get x squared to be a whole bunch of zeros. I'm going to put this in scientific notation. 3.96 times 10 to the negative 6. If from rounding, you just have 4 times 10 to the negative 6, or if you have 0.05s and then 396 or 4, you're fine. Square rooting that gets me my x value to be 1.99. I'm just going to call it 2 times 10 to the negative 3, or your calculator might say 0.002. That is our x value. Our x value represents our OH. So when I negative log that, I get 2.7 as my POH. 14 minus 2.7 will get me my pH of 11.3.